So in this recording, I'm going to do a walkthrough of today's activity. Again, this was the progress check using Pandas to analyze North Carolina health indicators. We have a couple ranges in this, and this was our first project where we were back to using Google Collaboratory. So we saw Google Collaboratory has a lot of benefits. One is that it incorporates text and coding areas. So you see a little area here where I have a little play button, which will run this little cell of code. And as I hover over, I can add more code cells if I needed to. Obviously, I can trash a code cell. I can also add text. So if I wanted to say, here's something about my code, I could do that, and it's now part of the notebook. So in this project, we started with this spreadsheet. It's a pretty big spreadsheet. It's got all North Carolina counties, and as I said in class today, there's 100 counties. North Carolina has an even number of counties at this point in time, and we have a lot of items across. So let's first start by getting this spreadsheet into our Google Collaboratory. So import pandas as PD, assigning this as our data frame, pd.read_csv, and then the link, I can just copy this CSV link that's already pasted up here, and I can see right here that its output is equal to CSV. So that's how I know that I'm working with a CSV. And then I want to see my head, df.head. What's helpful about this, that again, we talked about this in class, is that it's helpful that it's all showing a table and it doesn't show it as text. I don't need to print the head anymore, because when we print our head, we see it in text and it's not formatted in any table, and it gives me this ... right? So that tells me like there's a lot of information that's not being shown, and when I just run it like this, I now see it, and it's got interactive components, and it's got things like that. All right, so then task 2 says display the shape, so df.shape. Okay, so it's 100 rows, 101 rows, because there is actually, if you look at this data, there's one that is the total, or average, I guess, for North Carolina. Display the describe, df.describe. And what I see here is a table that has the mean, standard deviation, the minimum and maximum, and that kind of stuff. And again, we see 101, 101, 101, because we have 100 counties plus the state as a whole. Task 3, display the column headings, df.columns. And if you're curious about these, this is a good tool. There's this cheat sheet in Google Classroom, so you can see what does it do. So columns describe data frame columns, df.shape shows the rows and columns, df.describe shows a summary statistics, that kind of stuff. And this is a pretty handy document to work through. Okay, so we see that there's a lot of data here related to health indicators, and health indicators help the state notice trends or concerns in county by county. So we look here, I see a bunch of information about different types of cancer incidences. I see number of dentists per county or per 10,000 population, RNs, and more. So that's pretty interesting. There's a lot of data here to work with. So we're going to create a count by county, and by county is equal to our data frame with the index. Instead of it being set index, instead of it being on a 0 to however many rows we have, we're going to say our new index is based on the column county. And I can by county dot head see what that shows me. Okay, so I see now over here on the left side, instead of it being on 0s to 1, like I see on my table right here, here's my index 0 on, I now see it being by county. If I wanted to sort this, I could say sort the index and I should see that I'm sorting it by the counties like that. Great. So it says display this particular column, percent of very low birth weight, and give me the mean. So to look for a series, I use brackets. You see a bunch of options here, and I could scroll down until I get to the one I need, but I know that I've got that pasted, and I want something about this. In this case, I want the mean. Next one says do the same thing, but with a different series, and give me the median. Dot median. All right. Display county and the age-adjusted homicide rate. So if I want to get, instead of a single column, in this case, I want multiple columns. I create a list, county, and the age-adjusted. When I run this by itself, I should see a table. It's 2 columns. That looks great. And it says I want to give me the max. So I can do a sort by, sort values by that column, and let's assume that they're going up. So I need to do I could either do give me the value at the very end, -1, head of 1. I don't think it actually can work that way. So I'm going to do a ascending is equal to false. Robeson. Okay, so the same thing is going to happen. I'm going to copy this code down below, but instead of looking for the max, I'm looking for the min. So I'm going to say false is now true. And instead of looking at age-adjusted homicide, I'm looking at age-adjusted diabetes for a slightly different range as well. Okay, and when I run this, I should see Avery. Great. Task number 9 says look for these different columns. I'm going to do this. I'm going to do a by county, and I'm going to get a number of different columns. So the first one I'm going to get is this one. If I run that, I should see that it gives me the counties, and again I could do, let's make it always sorted. So this is equal to my set index of county, and then sort it by index. So it's now part of the definition of by county. So now when I run this down here, it's already sorted as well. Great. All right, so I need actually this value and then 2 other data columns in my spreadsheet. 2006 to 10 and 11 to 15. I think that the next range should be coming soon, so that's kind of interesting. All right, so I've got them all, but I wanted to narrow it down to just these particular options. And there were some really interesting conversations today in 6th period where I could do my counties, coastal counties is equal to, this string split by, split by commas. So you could do dot split by comma, and I should see a list. In this case, let's say print coastal counties, so we see what that looks like. Right? It's a list. That's very quick and smart to do. Then you can reference this, narrow this table by just those particular columns, and I can say something like this, reindex coastal counties. And I see that just those options showed up. If you don't want to do the split, you could obviously make each of these their own item in a list, which I think we did in most periods. So that's a pretty, if you don't want to have to manually create your list, you can use the split function, just like we might in Google Sheets, where you can do a split based on some sort of delimiter. You could do that. All right, so task number 10 says use this and find in this particular column and your county, these three columns rather, isolate it to just one. So by county, again, got a list of lists, so I need to have, so that goes like that, comma, comma, and I can run that and see that I've got my three columns, 1, 2, 3, perfect. And I want to narrow it to just person county. So I can do a lock, brackets, quote, person, looks like that. I could do the exact same thing. I can do a reindex, and then in parentheses, that, and it's going to print it, same exact information, right? So you can see that's the one before, yep, and then afterwards it's the same, but now instead of 212.6, it's going across, and it looks like a little table. Cool. Then we go to the next one. So I wanted to use iLock. So sorting this counties and this value. So df my county, and again this needs to be in double brackets because it's a list 2 items list. I want to sort values by what? By that. It says with the highest, so ascending is equal to false. And I want values from 5 to 9, so I do an iLock brackets 4 to 9. Should get me the 5th item, 6th, 7th, 8th, 9th. And if I wanted the 10th, 10. Great. 5th, 6th, 7th, 8th, 9th, 10th items. Great, something like that. Now I need to do a describe. We already did a describe up here, right? Gives me the values, and in this case it was the whole table, df. In this option number 12, we want to do it for just our county, and then these other 2 points. So start with our df, bracket, bracket, and then in quotes, county, that first range, the second range, and the last third range. Great. And I want to do a describe, and I should see in this particular case, it's averaging the entire data frame, and it says the mean, and I can see that over time for this particular statistic, age-adjusted stroke death rates, I'm seeing a decline. Just it's for the data frame as a whole. All right, so let's do the next 2. So I need to first create a scatter plot. So I'm going to say import matplotlib, and I can see that there's already a little shortcut there. Great. And I'm going to do a scatter. So we can do a number of things with the plt.scatter. And it says first your x and y. So let's pick 2 random topics, right? So I can do a df of my percent of my low birth weights. Let's pick that one. I mean, I'm really kind of picking them randomly, at least at this point. df, and then maybe a different range. So same, we'll do the same time but different range, like that. Yeah, that looks good. I think that'll work. And present it, right? So I could do plt.show, gives me my table, can add some details to it, right? plt.xlabel is equal to a string, in this case, percent of very low births, and then my y label, plt dot, actually I'll swap these, so this will be my low, y percent very low. I could do a title, plt.title. And I'm going to say, what is this doing? Birth weight comparisons. And I see my title, I see my different axis labels. That's great. So that's creating a scatter plot, plt.scatter. This won't really apply since I think we'll be fine, but if you wanted to clear the figure, you could do a plt.clf, copy my text cell, plt.clf would clear your, if you did another plt.show. Okay. So if I wanted to show, I didn't do the clear, I would see plt.show, that data still exists, I do my next, and sometimes it will show the data you already had. So we can do a plt.hist is our histogram. What I want to be is my two columns, or rather one topic. So I'm going to say my age-adjusted, and I can pick any of these things, right? I can pick any of them. We'll do this one, age-adjusted suicide rates. And this is a histogram, so it's going to show the number of frequencies that are occurring. Plt.x, let's first just run that as it is and see what I see. Great. Plt. What is my x is the age range. X label is age range. And plt.y label is my frequency of suicide. Okay, and my title, plt.title, is equal to, I'll just pick this column, age-adjusted suicide rates, 20, that can be my title as well. Awesome. And that is all of our tasks for this project. So again, bringing in my table and showing the shape, getting some statistical summaries to describe, getting the names of all my columns, dot columns, using a set index and sort index to create a new data frame that is my primary data frame, but using a different index, averaging a particular column, finding the median of a particular column, picking multiple columns and then sorting along one, in this case showing just that top value. Same thing, sorting descending, or sorry, ascending is true. This was using a reindex. Again, we took all of our columns, or sorry, all of our counties that are coastal counties, 20 coastal counties, split that string using the split method, and then use that as my reindex. Loc versus reindex, you see that? And then finding just the values in a particular sorted range using the iloc. Describe again, and then creating two tables. And that is all.